Dear students, in this video we are going to discuss about the structural features of ZEISES salt. Before going to discuss with this structural features of ZEISES salt, you need to be aware of the importance and the previous history of ZEISES salt. The ZEISES salt was actually reported by Professor ZEISES. When he was reporting this ZEISES salt, the chemistry, the entire chemistry world was amazing about how it was possible to make a coordination bond between a central metal atom and a pi bonded system. So, this was the milestone in the chemistry field, not only the chemistry field. After finding out this ZEISES salt, the entire medical world was actually amazing. Okay, so now we are going to discuss about the structural features of ZEISES salt. In this ZEISES salt, you can look this complex, this diagram. In this diagram, we are having the ZEISES salt, structure of ZEISES salt. In this ZEISES salt, the central metal atom is platinum, and this platinum ion is having the 4 coordination bond with 3 chloride ligands and 1 ethylene molecule. And moreover, the geometry of this complex is square planar, because we need to specify whether it is square planar or tetrahedral. You need to know that the 4 coordination complexes may have either square planar complex or tetrahedral complex. But here, from the X-ray diffraction analysis, we are coming to know that this ZEISES salt is having the square planar complexes. Then the pi electrons in ethylene. Here, you know that for double bonded compound, among the two bonds, one is sigma and another one is pi. And we know that the pi bonded electrons are very weak, therefore, they can be broken and they can be utilized for making the coordination bonds. So, the pi electrons in ethylene molecule are coordinated to the central metal atom. Overlapping of the pi bonding orbital of the alkene with a vacant sigma type orbital of platinum produces ligand to metal sigma type. So, here we have sigma and pi. This pi bond has two lobes. One is just lying above the two carbon atoms and below the two carbon atoms. So, among these two lobes, one lobe of pi bonding orbital giving its pair of electrons to the empty orbital of platinum, so that it forms a sigma interaction. Okay. In addition, a pi bond originating from the overlap of filled orbital of platinum with the empty pi bonding orbital of the alkene is formed. And moreover, we know that whenever a pi bond is formed, there is the possibility of formation of pi bonding molecular orbital. So, this one is pi bonding molecular orbital, and therefore, the empty high energy anti-bonding molecular orbital is also possible. Okay, this could be in this way. This could be oriented in this way. This is pi anti-bonding molecular orbitals. These pi empty anti-bonding moleculars orbitals, pi empty pi star means pi anti-bonding empty higher energy anti-bonding molecular orbitals are having the pi interaction with the filled platinum T2G orbitals. So, I hope you might have studied these things in the pi bonding or pi back bonding theory. Okay, so here we may have the T2G filled platinum orbitals. So, from this T2G orbitals of platinum filled orbitals can donate their electrons to the pi star empty antibonding orbitals of the alkene. Therefore, the sigma electrons were donated from the pi molecular orbital of the alkene is are actually returned by the platinum complex from the platinum metal atom. So in this way, the pi back donation actually was reported. So let us conclude. The pi orbital from ethylene, sigma orbitals are formed, and therefore pi acceptance was also taking place. Then this can be proved from the some spectroscopical evidences. The length of coordinated alkene, that means CC bond, carbon carbon bond, is 1.375 angstrom, is greater than C double bond C bond length 1.337 angstrom in the free ethylene molecule. Actually, we know that carbon carbon double bond must be 1.337 angstrom. But when these pi electrons are donated to the platinum central metal atom, this may have the partial pi bond character, or it may attain partial single bond character. Both are same. Therefore, whenever this carbon carbon double bond reduces from its actual pi bond character, its bond order may be reduced. Therefore, bond length may be 2 length. Therefore, the actual bond length of carbon carbon double bond increases from 1.337 to 1.375 angstrom. So this is the basic evidence that this carbon carbon double bond is making a coordination bond with the platinum. So this was actually returned here. This was actually written here. Then the carbon carbon double bond is perpendicular to the molecular plane. Okay. Then the originally planar ethylene becomes non-planar on bonding itself to the platinum. It is not amazing because the original planar ethylene, actually ethylene is planar because the all carbon carbon, because sp2 are hybridized, sp2 hybridized, but when it loses its double bond character, then it may lose simultaneously its planarity character. Therefore, the carbon carbon double bond or ethylene molecule becomes non-planar when it is having bond with the platinum metal atom. Then the metal located above the plane of the alkene symmetrically between the two skeletal carbon atoms. The two carbon atoms are almost equidistant, that means non-bonded distance from the platinum ion. The water molecule present in the salt is not attached to the metal, but it is accommodated in the lattice as a solvent molecule for crystallization. Actually, when this platinum ZEISES salt was reported, this platinum is 2 plus, therefore 1 minus. For water of crystallization, some H2O molecules may be there. Then only this ZEISES salt must be derived as a crystal. Otherwise, it is remaining soluble in its aqueous solution. But however, he was reporting that the H2O molecules which are not disturbing the central metal atom, or they are not claiming for the central metal atom for the coordination bond. Okay, so dear students, I hope you might have enjoyed this session of the structural features of ZEISES salt. If you need a more clarification, you can come to the chat box and you can clarify your doubts. So dear students, once again thank you for your passionable watching. Thank you.